So since you have not asked any queries or questions, therefore you have understood the amortized analysis. Okay. So let us discuss the divide and conquer method. So from the name itself, it can be assumed that when a problem is divided into n number of subproblems, okay, n number of subproblems, and then we find the solution of each subproblem, and after that we conquer or add all the solutions of all the subproblems to get the solution of the given problem. Okay, so that's why it is known as divide and conquer method. So we are having a lot of interesting examples and applications of this divide and conquer method, by which we can solve a lot of problems with uh, less complexity or lesser complexity. Okay, so let us first discuss one example, which is applying divide and conquer method. So the first that we are going to discuss is multiplication of two large integers. If there are small integers, we will not bother because these are constant. If the length of two integers are fixed, think about that. If the length of two integers are fixed, then the time complexity to multiply these two integers is constant or fixed, we can say. Okay, right? So here length of the integer means the number of digits in it. The length of an integer means the number of digits. So if the length of two integers are fixed, then the multiplication time or the time required to multiply these two integers are also or is also constant. So we will not bother about that case. But when this n is a variable, then what will happen? That means we want to multiply two integers of length n. Let both are of length n. It can be n cross m, so that is not a big problem. But here, for the simplicity, we are considering both the integers are very large and the length is a variable n. Now, how we can, if let u and v are two long integers of length n, this is also of length n, where n is very large. If we multiply these two by the simple multiplication algorithm, then the time required to multiply these two integers will be order of n, because there will be n number of digits and we will multiply each digit with the other. So we first multiply this, therefore n, and if we go on multiplying this with n number of the integers, then the time complexity will be order of n square. Okay. Now let us try to check that whether it is possible to find a divide and conquer, that is recursive algorithm, or not. After that we will go for finding the better divide and conquer algorithm. Okay. So let u and v are two given integers. We can write this u as w into 2 to the power n by 2 plus x, and v we can also represent, say, w x and y 2 to the power n by 2 plus z. We can represent any value, any integer as this. So let us consider one example where w, y and w, x, y, z are also numbers. Okay. So if, so okay. So let us consider a decimal number, let 2578. Okay. So what is the length of this? 4. So we can represent where, right, I forgot to mention that where w, x, y, z are of length n by 2. Okay. So we can represent n by 2, this w, if u is an n bit integer, then w is n by 2 integers, x is n by 2 integers. Therefore, here, since it is 4, we can write 25 into, since we are talking about decimal number, therefore our base is 10, length of the number is 4, therefore 4 by 2 plus 78. So here it is 25 into 100 plus 78. So we can write 2578. Okay. So for 2578, W is 25 and X is 78. Similarly, if we consider decimal number, binary digit, binary number, let 1000001 is equals to 129. So let us check for this. We can represent this as equals to W means 100 this into 2 to the power n by 2. Actually, we have to write this as base 2. So here it is base 2 plus 0 0 0 1. So here this is 2 to the power 3 and this is 2 to the power 4 plus this one is 1. So that equals to 2 to the power 7 plus 1, which is equals to 129. So therefore, any number, whether it is decimal or binary or anything, we can represent a number u as of length n as w of length n by 2 into 2 to the power n by 2 plus x, and v can be represented as similarly y into n by 2 plus z. Now, if we want to multiply u and v, we can write w into 2 to the power n by 2 plus x and y into 2 to the power n by 2 plus z. Therefore, from here what we can get, w into y 2 to the power n, right, plus w z x y. So we can write wz plus xy 2 to the power n by 2 plus xz. So in this way we can go for multiplying two integers. Again, this w can be represented as another one. Say this w again also can be represented as, say, p into 2 to the power n by 2, that is n by 4 plus another, say, q. Similarly, v also can be represented as, say, r into 2 to the power n by 4 plus s. So in this way, we can go for dividing the problems into sub-problems, and after that we can multiply each and then we can sum up with the solution. So here, for the first iteration, what we will get, u into v is equals to w into y into 2 to the power n plus z. So how many multiplications do we require? Okay, we require 1, 2, 3, 4. So we require 4 number of multiplications. Okay, therefore these 4 multiplications again require another 4 and so on. So because w will be divided into again 2 values p and q, this y will be divided into 2 values, this is y will be divided into r and s and so on. So can we write that the time complexity to multiply two integers of length n can be written as d, a fixed value, if the length is equals to 1. That means first we will divide all this sub problems into n by 2, n by 2, then it will be n by 4, n by 4, n by 4, and so on till we reach to 1, 1 in this way. And then we multiply each with other one. So w into v. Okay. So this digit will be multiplied with this one, this digit will be multiplied with this, and we will get the sum of all these later. So we are considering the constant time whenever the length of this integers are 1. Otherwise, we require 4 multiplication each of length n by 2 plus some constant b into n. Okay, because we are multiplying this n number of bits. So first we require 4 number of multiplications which are containing n by 2 number of integers. Therefore the length of this, and to multiply this n number of, we require n multiplications, therefore b into constant n. So if we solve this by master theorem, we can get the time complexity is order of n square. Okay, you can recheck this because a equals to 4, b equals to, you can check that what fn is equals to n to the power log a base b, which is, and that we can write n to the power and n to the power fn can be as n to the power 2 minus 1, which is equals to n. So n can be written as this, fn equals to this. Therefore from the first case of master theorem, we can write n equals to big O of n square. Okay. Now the question is it possible to decrease this value? I think you have understood that how we have got big O of n square for multiplying two integers using divide and conquer method. So here you see, in this case we have not decreased, or we are unable to decrease. We have not got the success to the algorithm. Okay, but here instead of multiplying sequentially one by one, we have applied the divide and conquer method or the recursive method, and we have solved the problem. But still the time complexity is order of. Now let us check, is it possible to decrease this value? Okay, so let us first analyze the property of the multiplication. So what we have uv is equals to wy 2 to the power n by 2 to the power n, w into this 2 to the power n, right, 2 to the power n plus wz plus xy 2 to the power n by 2 plus x into z. So here we require 4 multiplication. 4 multiplication. Okay. Now let us check this wz plus xy. We can write this wz plus xy as w plus x into y plus z. Okay, so we will get wz xy, and we are having two more terms which are wy and xz. So we can subtract these two values, wy minus xz. Now think about, here we are already multiplying wy, here also we are multiplying xz. So to find wz plus xy, okay, we require only one multiplication. Think about that. To find the value of wz plus xy, we require only 1 because w plus x into y plus z. And another two terms already we have got from here. So we don't have to remultiply these two. Okay. So therefore, what we can write, instead of writing this value, we can write u into v is equals to wy. We will multiply wy 2 to the power n plus w plus x into y plus z minus wy minus xz. Okay, into 2 to the power n by 2 plus xz. So here we require 1, 2 and 3. Three multiplications we require. Okay. So therefore, we can write the time complexity or the recursive definition as equals to Tn is equals to simply d when n equals to 1, and if this is not dq, this is d for n equals to 1, else 3n by 2 plus b into n for n greater than 1. Okay, when n greater than 1. So we can write the recursive definitions Tn as equals to this. Now if you solve this problem by master theorem, you can get that Tn is equals to big O of n to the power log 3 base 2, which is equals to big O of 1.59. Now see, this is a big difference from 2. So from us it may be look like that, sir, what will happen with 0.41? Yes, but think about when n tends to infinity. That is, we are going to multiply two large number where the length tends to infinity. That is so large that we cannot imagine also. Then this 0.1, 0.41 will play a big role. Okay. So we can multiply two variable length large integers by using this divide and conquer method, and that will take very less time than the general multiplication order of n square. Okay. So if you have any doubt, you can ask, otherwise I will go to the next. I think this is very simple example and simple algorithm. But still, if you have any doubt, please, you can ask.
No, sir.
Okay. So let us go for matrix multiplication algorithm. Okay. So we are having two matrices to multiply. So let A11, A12, A21, A22, and we are having another matrix B11, B12, B21, B22. Okay. If we multiply these two and store it into a matrix C, then we know that we have to multiply A11 with B11, A12 with B21, and we will get the C11. So let us write A11 B11 plus A12 B21. Similarly, we will multiply this with this, that means A11 B12 plus A12 B22. Then we have to multiply A21 with B11 plus A22 with B21, and then A21 with B12 plus A22 with B22. So how many multiplications do we require? We require 1, 2, 3, 4, 5, 6, 7, 8. Now think about two large matrices. What we can do? We can consider, we can divide this. So let this is of length n cross n. This one is also let n cross n. Let us for square matrices. We can divide this into n by 2 cross n by 2 like this, n by 2, n by 2 cross n by 2 and so on. Okay. So here also n by 2 and all these. Now to multiply these two matrices, actually we are multiplying this matrix with this matrix plus this matrix with this matrix. Okay. So if we go on recursive definition, actually what are we doing? We are multiplying two n by 2 cross n by 2 matrices with each other and taking the sum. Again this n by 2 cross n by 2 can be divided into n by 4 cross n by 4 and so on. So if we go on dividing the problem of matrix multiplication into sub problems, we will go on dividing till we reach this. This is not 1, actually these are elements. Okay, we reach to this one. That means each is containing single element. So we will go on dividing the problems into sub-problems till we reach that each sub-problem contains single element. So we will multiply it this way, right? We will multiply this way and get the sum. Then in the next higher level, these two values will be considered as the element of a matrix and will be multiplied and so on. So we can write, therefore we require how many? 1, 2, 3, 4, 5, 6, 7, 8. We require 8 number of, we require Pn is equals to say constant when we have the matrix as 2 cross 2. Otherwise we can write 8 T of n by 2 plus some constant into n to multiply this. Okay, to multiply this. So if we go on finding this by applying master theorem, we can find that the time complexity is order of n cube. Okay, and which is very much known to us that the time complexity for matrix multiplication is of order n cube. That already we know, and why this is? Because of this thing. Okay, if we multiply two n cross n matrices, the time complexity is of order of n cube. Now the question is it possible to decrease the value? That is our main target. So let us check that whether it is possible or not. Okay. So here the researcher Strassen, one mathematician, actually basically Strassen, the mathematicians developed one algorithm to multiply two matrices. How? He has considered 7 terms like P1. P1 is A11 where we are considering two 2 cross 2 matrices. Okay, it can be this is A, and it can be implemented into n cross n also. There is no problem. B12, B21, B22. So here I have written in upper class, so you can write this A12, A this one. Okay. So Strassen considered 7 terms where the first term P1 is equals to A11 into B12 minus B22. If you ask that how he has got these values and so on, so that I cannot reply, because Strassen has thought like this, and after devoting so many days and so many hours, he found this. Okay, so this is his idea and his brainchild that if we follow this path, then we may get the solution. Okay, so there was no tricks like that. One fine morning he wake up from the bed and wrote all these. No, he thought for so many days and found the algorithm. Okay, so the first term he considered is A11 multiplied with B12 minus B22. So we require one multiplication for finding the term P1. Similarly, he added A11 with A12 and multiplied with B22 to get the term P2. So we require another multiplication, so altogether 2. Third, A21, A22 multiplied with B211. So again we require one multiplication. Similarly, here A22 will be multiplied with B21 minus B11. So 1. Here, two terms are added from the A and two terms are added from the B. A11 plus A122 multiplied with B11, B12. We require one multiplication. Similarly, here we require one multiplication. Here also we require one multiplication. So altogether, we require 7 multiplications, right? Where the size of each, if we consider n cross n, the size of each element A11, B11 like this is of n by 2. Size is n by 2. Okay. Then what he did? He found the solution of C11, C12, C21 and C22 as like this. C11 is equals to P5, this one, plus P4 minus P2 plus P6. If we calculate this term, we will get C11. C11 means A11 B11 plus A12 into B211. Sorry, write it in capital. Okay, so easily we can find this. Next, P12 is equals to P11 plus P2. Sorry, P1 plus P2. P21 is equals to P3 plus P4. C22 equals to P5 plus P1 minus P3 minus P7. Okay, let us check for one. I am considering the simplest one. Say C12. P1 plus P2. Okay, you can check the others. If you find anything wrong, so let me inform. So P1, what is P1? P1 equals to A11 multiplied with B12 minus B22 plus P2 is equals to A11 plus A12 multiplied with B22. Okay. So that equals to A11 B12 minus A11 B22 plus A11 B22 plus A12 B22. That is equals to A11 B12 plus A12 B22. Let us check whether P12, that means this term, is equals to this one or not. So this means first row, second column. So therefore we must get A11 multiplied with B12 plus A12 multiplied with B22. Yes, we have got the same. Therefore, if you check for C21, C22 and C11 also, then we will find that this is giving us the correct result. Okay. So in this way, we can solve the problem by using 7 multiplication. So then, what will be the recurrence? Instead of Tn equals to 8Tn by 2 plus b of b into n, we can write from the Strassen's algorithm, we can write the recursion as 7Tn by 2 plus some constant b into n. Okay, so therefore by applying master theorem, we can write that Tn is equals to big O of n to the power log 7 base 2. So I think this value is n to the power 2.89 something, or 91 maybe. I have to check. Okay. Log 7 base 2, most probably this is 2.89 or maybe 2.91. Can you tell me that what is the value? Anyone? Value of log 7? Yes, 0.8. Please tell me.
Log 2 base 27
Base
2
2.
no
Base
2.80
2.80, right. So,
807.
okay. So we can consider 2.81, right? So we can consider this as 2.81. Yes, 2.81. So therefore you see that uh, we are able to decrease the value by 0.19. Now you can say that, sir, why we should go for decreasing this value by 0.19? Because this is too complicated. We have to calculate so many things. We have to remember so many things. Yes, right. You are very correct that only 0.19 is not a very big value to think about all these. Hence, we can think that, well, Strassen ने क्या कर दिया? This is a very small value. Now think about a large matrix you want to multiply. Say suppose you want to find say what I can say, I forgot, in DBMS, which is known as uh, joining. Think about, I think you have studied in DBMS different kind of joins, natural join and theta join, outer join, and so many things. So if we go on joining, select both left and right, both outer joining. So what will happen? Each of the records will be multiplied with each of the records of another matrix or database. And suppose you are talking about a big or large database, okay, very large database where there are a lot of data like Facebook or Twitter or something like that. Now, you think about that, what will be the multiplication time if we follow into the power 3, and then 0.09 will be a big factor, okay. So therefore, for a small example that we are capable to think about, uh, is not will not be that much of fruitful, and that's why n cube, order of n cube, this matrix multiplication is very famous, okay. Strassen is not too famous, but whenever the size of the matrices are very large, then only it will be helpful, okay. So it is not that 0.19 is not a big term, but when n tends to infinity, this will really very helpful, okay. So in this way, by applying divide and conquer method, we can develop better algorithm. One is, already we have shown two examples. One is for multiplications of two integers, and another is for Strassen matrix multiplication, okay. Next day, sorry, not next day, this closest pair of points is your home task. You have to read it by yourself and you have to make your own note. I will not going to discuss, because what happens, if I discuss all these topics and uh, the algorithms, you may lose some interest to read the books and the chapters, okay. So I prefer that I will discuss most of the algorithms, but I will give you some of the home tasks to solve by yourself. By 2 or 3 days, I will supply some assignments to you so that you can solve and you can get some experience and ideas by solving all these problems. I will send it to your mail ID or maybe through the WhatsApp group. Okay. So this closest pair of points, this algorithm is home task, and within 2 or 3 days, I will supply some assignment for solving, because most probably at the end of February you have either class assessment or midterm. I forgot. So you please check your routine. Okay, routine means uh, the schedule, academic schedule that is given to you. You check and inform me whether it is class assessment or the midterm at the end of
Sir,
February.
it is class
It is
assessment, sir.
class assessment.
Oh,
CA1.
class
Sir, it's CA1. It's CA1.
CA1. Okay, so
Yes,
that
sir.
means I can supply some assignment, and if you submit this, that will be okay. So I will
Yes.
talk with some the other teachers from the other department, sorry, not department, sections, and I will try that what they are following, and accordingly I will also do that. Okay, or we may follow something different from others. That I will take care. No need to worry. But whatever we are discussing, please you read all these, and if you have any doubt, immediately you can ask. You can ask me through personal message also. You can put it within the group so that other people may have the same questions and they will be aware that okay, I can also ask this type of question. But if you do not study this, it will create a problem, because wherever you go, that to industry or for MTech or PhD, whenever or wherever you go, this topic will be required throughout your whole life. This design and analysis of algorithm. Okay, so please be careful, not only for the marks, but you try to learn, you try to develop something new, and try to think about something new, so that you get some interest on this topic. Okay, so today I will finish up the discussion, since already we have discussed two topics and this is the home task. Next day, linear time median finding algorithm, and if I get time, then convex hull algorithm. Already we have some idea about convex hull and how to solve, but here I will write the whole algorithm and explain with an example. But before that, these two algorithm, multiplication of two large integers and Strassen's multiplication, this closest pair of points. Okay. Now, if you have any doubt or query, you can ask.
Sir, can you explain a bit what we have to do in the closest pair of points?
No, I will not explain anything.
Okay, sir.
You have to find it from the book or the any material. Okay, document.
Okay,
I
sir.
will suggest to read the book. Don't go for study from the website. Okay, or any uh, document that is available. If you want to study, then go to some universities like MIT or Stanford or IIT. But wherever you get some documents, don't go for studying, because the popular ones are not always correct. Okay, so you may be misled by all this. So you are having in your curriculum 3 or 4 books are given. You can find from this. So I will not say anything about the closest pair of points. If you find any difficulty after study, then I will discuss. Okay, but
Okay,
first
sir.
try. You try to find as if you have to take the class. So in that way you prepare your note. Clear?
Okay, sir.
Okay.
Yes, sir. Yes.
Okay. So do you have any query about this, that two examples that we have discussed? No.
Sir, no, sir.
No, sir. That's matrix one, sir. Okay.
Okay. Okay. So then I can leave. Okay.
Okay, sir.
Thank you. Thank you.
Thank you, sir.